So our objective for today, for 2-4, are the students to be able to write equations of quadratic functions using vertices, points, and x-intercepts. And the students will be able to write quadratic equations to model data, which we're going to do the second day that we work on this. So today we're just going to work with the first objective. So a couple core concepts we're going to work with. We're going to take and we're going to write quadratic equations given a point and the vertex. And so if you're given a point on the parabola, so if we have any point on the parabola and the vertex of the parabola, we'll use vertex form, which remember is y equals a times x minus h squared plus k. And so the steps we're going to use to do that, you'll plug in the vertex values for h and k and the point values for x and y. So your vertex values are your hk, and then the point values that also are on the parabola you'll plug in for y and x. Then you solve for a, and then you simply write your equation in vertex form. So I'm going to go through several examples. As soon as you feel like you've got it, you can stop and go on to the next part. But make sure this makes sense to you. So we know that it passes through the point 6 and 12. So remember, that's our x value and that's our y value. And this is our h value and this is our k value. So we're plugging this into vertex form. So our y value is 12. So we're going to plug in 12. Equals our a value we don't know. That's what we have to solve for. So our a value is what we're going to solve for. And then our x value is 6. Now remember it's minus 8, so opposite what it says, so minus 3 squared plus k, and our k value is 7. So we simply plug those values in, and now we solve for a. So over here I get 6 minus 3 is 3 squared. So we're going to move that 7 to the other side by subtracting 7. And so we get 5 equals 3 squared is 9, so I'm going to write that as 9a. And then we simply divide both sides by 9. And so now we know that a equals 5/9. And so now we can write the equation for the parabola. It's y equals 5/9 x. We know our vertex is 3, 7. And so now we've got the equation for the parabola. We know our vertex is at negative 3, 7. Our a value is 5/9. We can make a chart and graph that if we needed to. But all we're going to do is write the equations. So let's take another one. So again, it really will help if you'll just label everything. So this is my x, this is my y, this is my h, this is my k. So negative 7 equals a times x, 5, minus 10 squared plus 3. So I'm going to subtract the 3. Subtract the 3. And so we get negative 10 equals 5 minus 10 is a negative 5, and negative 5 squared is 25, so that would be 25a. So now we divide by 25. So our a value would be negative 10 25ths, but we should always reduce. So our a value is really, 5 goes into both, so that would be a negative 2/5. And so this would be y equals negative 2/5 x minus 10 squared plus 3, and we have our equation. So now we know our vertex is at 10, 3. We know it opens down, and we can find the values. And the last one of this type, again, I'm going to just label the values, x and y, h and k. So negative 5 equals a times 0 minus 4 squared plus 0. So moving the 0 doesn't change anything. Negative 4 squared would be 16. Divide by 16. So A equals negative 5/16. And now we write our equation. So that will be negative 5/16. And then x minus 4 squared, and our k was 0, so we're done. So pretty easy. Label it, plug them into the equation, and solve for a. So that's the first type we're going to do. The second type is now, instead of a point and the vertex, we're going to be given a point and the x-intercepts p and q. And if we're given that information, we want to use intercept form, which remember is y equals a times x minus p times x minus q. So our steps are to plug the x-intercepts in for p and q and plug in the point values for x and y. Then again, we solve for a, and then we write our equation in intercept form. So, example. Given the point 312, so that's my xy. This is my PQ. Really doesn't make any difference which one you call which. And so now we plug it into our equation. Y equals a times x minus p times x minus q. So in this case, our y is 12 equals a. Our x is 3 minus p, but minus a negative 3 becomes plus 3. And then again, it's x again, so again we plug in 3 minus 8. And now we can solve for a. So we get 12 equals 3 plus 3 is 6. 3 minus 8 is a negative 5. So we get 12 equals 6 times negative 5 is a negative 30a. And we divide by negative 30. Reduce that. 6 goes into both. So we get negative 2/5 is our a value. And now we can write our equation. Y equals our a, which is negative 2/5. And then x minus a negative 3 becomes plus 3. And x minus 8. And we have our quadratic. Remember, you're going to get your quadratics of x squared, but when we FOIL that, we would get x squared. So let's try another one. Again, it's simply a matter of labeling x and y, p and q, and then plugging them in. So y is 5 equals a times x, which is negative 2, minus a negative 5 becomes plus 5. And then negative 2 again, remember that x doesn't change. And then minus 3. Simplify. Negative 2 plus 5 is 3. Negative 2 minus 3 is a negative 5. So if I multiply that, we get 5 equals negative 15a. So we divide both sides by negative 15. 5 goes into both, so it would be a negative 1/3 is our a value. And now we can write our equation. A is negative 1/3. X plus 5. X minus 3. One more. Again, you may feel like you've got this now, so you can skip this if you want. But just in case, you can try it and see if you get the same answer I get. So we label it xy, pq. So 2 equals a, 3 minus 2, 3 plus 8. 3 minus 2 is 1. 3 plus 8 is 11. So we get 2 equals 11a. Divide by 11. So a equals 2/11. So we can now write our equation. Y equals 2/11 x minus 2 x plus 8. So again, both methods, you're simply plugging in the values into the equations to solve for a and get your equations. The last one, a little bit more difficult. So, given 3 points, we're going to write and solve a system of 3 equations and 3 variables. Now I'm going to go through one example on this. It stays the same. We're solving 3 by 3 equations. So we're going to follow these steps. First thing we're going to do is use the equation ax squared plus bx plus c equals y. Then we're going to write 3 equations using each of the ordered pairs for each equation. And then we're going to solve the system of equations. So, remember, we're using this equation, and remember what these are. These are x, y. So you're going to use one set for each equation. So I'm going to go up here, and my first equation is going to be a, which we don't know. But we do know x. X is 2, and 2 squared is 4. So I'm just going to put the 4 in front. Instead of a times 4, I'm going to put 4a plus, now again, this is x, so I'm plugging in 2. So that would be 2b plus c. We don't have a c value, so that just stays there. But we do have the y value as negative 12. So this ordered pair we use to give us our first equation. Okay, just plugging it in. So now I'm going to use this ordered pair to get my second equation. So again, we're plugging this value in for x. So 3 squared is 9. So we get 9a plus 3 in for x. So b times 3 would be 3b. Again, it's plus c equals 13. And lastly, I'm going to use this ordered pair. So I'm plugging, this is for equation number 3. I'm plugging negative 3 in for x. So a negative 3 squared would be a positive 9, so that would be 9a. And then I'm going to plug in negative 3 for x, and so that would be minus 3b. And then I'm going to plug in, I don't know c, so that stays c, but I'm going to plug in 43 for my y value. So now we have 3 equations with 3 variables. And so we can go ahead and solve that. Opposites. Now on these, I would always make the c's opposites. Okay? And so let's just use equation 1 and equation 2. So I'm going to take 4a plus 2b plus c equals negative 12. And I'm going to multiply this equation by a negative 1. So negative 9a minus 3b minus c equals negative 13. So again, I wanted to make these c's opposites, so I multiplied this one by a negative 1 and changed all the signs, and now we add this together. So we get negative 5a, and then 2b minus 3b would be a negative b equals a negative 25. Now I'm going to go ahead and use 2 and 3. And again, I want opposites. So I'm again going to multiply this second equation by a negative 1. So that's going to give me negative 9a minus 3b minus c equals negative 13. And this equation is going to stay the same, so I'm going to add these two together. Well, in this case, the a's cancel. I get minus 6b. The c's cancel. Equals 30. I can divide by negative 6. And so I get b equals negative 5. I can now plug that in. So negative 5a minus the negative 5 becomes plus 5 equals negative 25. Subtract 5. So negative 5a equals negative 30. And so a equals 6. And now I can plug that in to any one of my equations to solve for c. So I'm going to plug it into this one up here. And I'm going to get 4 times 6 plus 2 times the negative 5 plus c equals negative 12. So we get 24 minus 10 plus c equals negative 12. 24 minus 10 is 14. And subtract 14. And so I get c equals negative 26. So if we did that right, we now have an equation. We have a is 6, so that would be 6x squared, because we're plugging it back into our quadratic. B is negative 5, so minus 5x minus 26 would be our quadratic. Now let's just check that and make sure by using another one of these. So let's check it in this one. So 9 times 6, that would be 54. 3 times negative 5 would be negative 15. And then minus 26 should give us 13. So 54 minus 15 is 39. Minus 26 equals 13. So we know I got it right, and so this gave us the solution for our quadratic. So, what you're doing on this, again, you use the 3 ordered pairs. Each ordered pair gives you one equation. You plug these in for x. Remember, you have to square it, so it's ax squared. Use the same value 2 for bx. And then the c just stays c, and then you plug in the number for y. And then once we solve and get our a, b, and c, we can write our quadratic function, f of x or y or whatever. So these take a little bit of time. You only have one of those to do on the assignment. So your assignment is on page 80, 3 through 14, all, and number 25, which is the 3x3 equation. That'll be on the Big Ideas Math, so good luck.